Hi folks, we're going to take a look at number 13C and E from the Unit 5 assignment. So let's take a look at C. So I see here that I have 2 to the negative 1 plus 2 squared. So the first thing to recognize is that there's no exponent law that can help us simplify this directly, okay? Because the operation between the two powers, even though they have the same base, is an addition. It's not a multiplication or division. So that means I'm going to have to do this the long way, meaning I have to first start by simplifying each of the individual powers, okay? So 2 to the negative 1 is the same as 1/2, and then of course 2 squared is 4. So if I want to simplify this, I have to add these as two fractions, all right? So of course we do that by writing them both under the same denominator. So this is 1/2 plus, and how can we write 4 as a fraction over 2? Well, that's going to be 8 over 2. And so our final answer is going to be 9 over 2. Okay, so in the end, this ended up being a question about adding fractions. But the main thing to see here is that there's no exponent rule that allows us to simplify this working, even though they do have the same base. Okay, so let's move on to D. Actually, sorry, this is E, not D. Okay, I'll fix that there. So there's a few ways that you can proceed with a question like this. So certainly one way is to simplify everything in the bracket and then worry about the exponent. The other option is to distribute the exponent to numerator and denominator. That's probably the longest way. And another thing you can do, which maybe is in terms of amount of time is in between, but I think it's the one that allows for least errors, is to first start by applying the negative portion of this exponent. So we know that when we have a negative in the exponent, the effect is to give you the reciprocal of the base. So the first thing I'm going to do is I'm just going to apply the negative part of this exponent to that base, which is that whole thing in the bracket. So it's going to give me the reciprocal. So that's going to be 4x to the 4, y cubed, z to the negative 1, w to the negative 3, all over 3 times x to the 5th, y, z to the negative 3, and w cubed. Okay, and so this is now going to be just squared because I've already incorporated the negative portion of the exponent. Okay, now I'm going to go ahead and simplify what's inside the bracket. Okay, so the 4 and the 3, well, there's nothing to simplify there, so that's just going to remain 4/3. Okay, and now we can apply our exponent law for divisions. So here, x to the 4th divided by x to the 5th, I subtract the exponents, so this is going to be x to the negative 1. Okay, next, y cubed divided by y to the 1, so when there's no exponent. Now, one common mistake that you got to be careful of is this negative 3 only applies to the base z. It doesn't apply to the y. There would have to be brackets in order for it to apply to the y. So here, this is like y to the 1. So 3 minus 1 is 2, so y squared. Okay, z to the negative 1 over z to the negative 3. So it's negative 1 minus negative 3, which is the same as negative 1 plus 3. So that's going to be z squared. And then here, w to the negative 3 over w cubed, it's going to be negative 3 minus 3. So w to the negative 6. Okay, and all squared. Okay, so again, I can rewrite this in fraction form. I could apply the exponent. I think either way would work just as easily. But another common error, this is probably the one that's most common of all, is to forget that when you've got this big expression in the bracket that's being squared or cubed to any exponent, is this exponent applies to everything, including the number part. Okay, so that's the part that people often forget. So make sure that this square also applies to the coefficient 4 over 3. So 4 over 3 squared is going to be 16 over 9. So here, as I apply the exponent to all of these, I have the power of a power, so I'm going to be multiplying the exponents. So this is going to be negative 1 times 2, so x to the negative 2. This is going to be 2 times 2, y to the 4. This is again 2 times 2, z to the 4, and negative 6 times 2 is w to the negative 12. All right? And this is where we have to remember the convention. And the convention is that we always give our answers with positive exponents. So these expressions that have negative exponents need to go into the denominator. since that's the effect of the negative exponent, is to give you the reciprocal. So take it from the numerator into the denominator. So what am I left with in the numerator? I've got the 16 that's going to stay in the numerator, and these two expressions with positive exponents, so y to the 4, z to the 4. And then in the denominator, well, I'm going to have my factor of 9, and then I'm going to have these two negative exponent terms, which are going to go into the denominator. So this is going to be x to the positive 2, and this is going to become y to the positive 12. And so now I have a fully simplified answer. Okay, so let's just do a quick recap here. So in C, the main idea to get out of C is to make sure that you don't try to make up exponent rules for additions of powers or say subtraction of powers, because there is none. So here I had to do it by working with the individual expressions, and then I was able to add them as fractions. Okay, in this one here, there's many ways to proceed, but my suggestion is to first apply the negative exponent to take the reciprocal of the base, which is this whole thing in the bracket, and then from there simplify, apply the exponent on the outside of the bracket, and then make sure you rewrite your answer with all the exponents being positive. Okay, that's it for these.